this next example is really the first example of a true battery. And that's the lead acid battery. That's the one that would be your car battery. And the reason why a battery is called a battery is because it's a series of electrochemical cells. Anytime you have a series of anything sort of lined up in order, it's called a battery. Like you can have a battery of tanks in an army unit and that sort of a thing. So a battery is really a word that should indicate that you have more than one cell placed in series. But it's used generically also in the common language or in layman's terms to indicate a dry cell battery or a voltaic cell. Excuse me, a dry cell or voltaic cell are often referred to as a battery. But in the truest sense of the word, the only batteries are ones in which you have several cells lined up, as is in this case. You have 6 individual cells. They're each produce 2 volts to give you a total of 12 volts. So when you put these cells in series, their voltages are additive. And you can see out here how they're connected, physically connected in series. In this particular type of a battery, I have the entire redox reaction written right here. And you can tell by looking at the reaction, you ought to be able to tell by looking at the reaction, which is the undergoing oxidation and which is undergoing reduction. Okay, right here it says negative plates filled with spongy lead, positive plates filled with lead oxide. So the negative, remember, what does negative always indicate? Negative indicates the anode, and positive in these types of spontaneous cells indicates the cathode. So from that, you know, the cathode is the side of the reduction and the anode is the side of the oxidation. So you ought to be able to look at this chemical reaction and either by reading this right here or just looking at the various oxidation states, that's 0, that lead is +4, and over on the product side, this lead is in the +2. You can see that this lead is undergoing oxidation. So this is what's occurring at the anode, and this lead oxide is undergoing reduction. The product of both the oxidation and the reduction is the same. So one lead, there's 2 lead 2 sulfates here. So one of the leads is being oxidized to lead 2, the other lead is being reduced to lead +2. And also notice here in this oxidation reduction reaction, the arrows are pointing in both directions. And what happens, this is the first example of a rechargeable battery. So as you can see here, when this reaction is moving to the right, when the circuit is completed, the reaction will run to the right and you'll form the product lead 2 sulfate plus some electrical energy. Okay? And but this particular lead storage battery is rechargeable. This is the first example of a rechargeable battery. And so what happens is, in this case, if you add energy, electrical energy, to the system, you will drive the reaction in the opposite direction. And this is really important. This is why or how rechargeable batteries work. Regular batteries, they run out, they run down, they stop working, they die when they either run out of reactant or the reactant concentrations become very, very low and the reaction can't be sustained. So that's why we have to throw batteries away, or we say batteries go dead. But in the case of rechargeable battery, the battery has been designed and the reactants and products have been chosen such that it can, the reversible reaction can occur relatively easily, and it's physically set up such that when it's run in reverse, the reactants that are reformed will return to a place such that they will still be physically separated in space. So even though it's the same reactant, the same product, the reactants that are regenerated stay separated physically in space so that you can continue to harvest the electrical energy because the reactants, oxidation and reduction reactants, are physically separated. So anyway, this is the first example of a true battery and also a rechargeable battery. Okay.